And here we go. Okay, so I'm going to define the slope field, what it is, a couple times today. It probably won't make sense to you until about the third or fourth time I've described what it is, okay? So today we're going to make a slope field, okay? What a slope field is it's a graphical representation of every general solution on a single coordinate axis. Okay, I'm going to say that again because it's going to sound really weird, right? Okay, it's a graphical representation of every general solution on a single coordinate axis. Super weird, right? So I'm basically telling you on one single XY coordinate axis, I'm going to plot an infinite amount of graphs. Weird, right? Okay, so let's try one, and we're going to slowly start to understand, okay? Now, whether you think you can visualize the general solution or not, I don't want you to solve it, okay? So let's say I gave you something like this, okay? So we're going to start with an easier one. I don't want you to even think about what y would represent. Don't think about finding the antiderivative equation for this yet, okay? I'm going to go ahead and I'm going to draw an axis. Those of you with those notebooks with the dots in it, this is your time to shine, my friends, because we are about to make a bunch of dots, okay? So, we're going to play the dot game a little bit from -3 to 3.
What the heck?
I'm making the field.
I do the field.
You'll be fine. Okay.
Whoa, okay, just keep it long. Just what?
So I have now created a field. Okay. Yeah.
Captain, vertical barriers are down.
Okay, so now I'm going to plot slopes in my field. Now remember, I'm making a graph of y, okay? So I'm making a graph of position. I'm making a graph of y, but I'm using the velocity. I'm using slopes, okay? Now, because I don't know what y is and I don't know what c is, my plus c, I actually have no idea where on this graph my y is going to go through. Is that fair to say? Okay. So I have no idea if this graph goes through this coordinate point here at -3, 3. But if it did, what would its slope be?
Just X.
So what number?
So 1.
Nope.
Negative.
-3. Because the slope at any point is the x coordinate at that point. So I don't know if my graph goes through the coordinate point here at -3, 3, but if it did, the graph would have a slope of -3 there. Okay, so then I'm going to plot it. I know that doesn't make sense yet, but just stay with me, okay? Now, I don't know if my graph goes through the point here at -3, 2, but if it did, what would its slope be? -3. I don't know if my graph goes through this coordinate point, but if it did, what would its slope be?
-3.
Okay. I don't know if my graph goes through this point, but if it did, what would its slope be?
-3.
Okay. I don't know if my graph goes through this point, but if it did, what would its slope be?
-2.
So it doesn't have to be perfect. I just draw something maybe a little less steep than the previous one, right? I don't know if my graph goes through this point at -2, -3. But if it did, what would its slope be?
-2.
Okay. I'm going to start jumping around. I don't know if my graph goes through this point. But if it did, what would its slope be? Okay. I don't know if my graph goes through this point. But if it did, what would its slope be? Okay. I don't know if my graph goes through this point. But if it did, what would its slope be? Okay. How do we draw a zero slope? Okay. Finish the slope field. Okay? I want you to fill in all the dots. Okay. Gotta move faster, my perfectionists. She even has the dots.
We all looked at her.
Okay. Now, I'm going to say one more time the definition, and then we're going to make some connections here. Okay, a slope field is a graphical representation of every possible general solution on the same coordinate axes. Okay, so think about that, and now we're going to solve the algebra for the y. Okay, so we're going to do what we did last time. So I'm going to solve the general solution. So I'm going to times both sides by dx. So dy equals x dx. I'm doing okay? Integrate. So y equals x squared over 2 plus c. What family of function is this? Parabola, quadratic. And what does the plus c do in terms of a transformation? What's the shift? Up and down? Okay, so you're saying that every possible general solution of this is a quadratic, right? With a vertical up and down shift.
I'll just say it kind of looks like that.
Now I want you to kind of imagine this on this.
Austin, you're so smart.
And I'm going to say the definition one more time. The slope field, okay, the slope field is a graphical representation of every single possible general solution on one axis. Can you visualize the parabolas being moved up and down? Right?
Every possible what?
General solution.
So this for every possible value of c.
Every possible value of c on one graph. Yeah. Now, wait a minute. Let's clarify that. I just chose to do a dot at every one. I could have chosen to do a dot at every half or every quarter, right? Technically, what would the slope field look like if I did every single possible value of c? Yeah, it'd be a shaded in box, right? It'd just be a square all shaded in. I can't do every single one, right? But we can get close, right? And I could get as accurate as I wanted to. You with me? Okay, does anybody have any questions so far?
This is only from -3 to 3, right? So there's still like a range to it.
On this one, but it doesn't matter. I could have made the range anything I wanted, and the pattern would have continued.
Yeah, but it's not like every.
Right, because that's what we were just talking about. What would it look like if it was every point?
It'd just be
A big shaded box, right? Yeah. So we have to decide what domain we're going to limit it to, and we have to decide how accurate we want it. Do we want halves or quarters or whatever, right? But you get the idea, right? Do you guys see the parabolas? Okay, so let's try another one. Okay, we're going to try this one, and we're going to start together again. Okay?
Yeah, the road.
dy over dx equals negative x over y. I don't want you to solve anything yet, okay? Now, to make it go a little faster, I like to start with the axes, and then I kind of like to start somewhat on the diagonals, okay? Because this one is going to take a little longer because the slope equation has an x and a y in it, okay? Okay, so let's look at the x-axis. If a line is, I don't know where this graph is going to go. I'm going to do -3 to 3 again, okay? I just don't feel like drawing all the dots. I'm going to use my graph paper, okay? I don't know if my graph goes through -3, 0, okay? But if it did, what would its slope be? Negative, it'd be +3 over 0. Divide by 0 error, it'd be undefined. Okay, so you can do a little vertical line if you want. I'm just going to leave mine blank. Okay, so that's for the whole x-axis. Is that fair? Because that's all the divide by 0 errors for y. You with me? Okay, now let's do the y-axis, excluding 0, 0, right? Because that one's still undefined, divide by 0 error. Okay, so if I don't know if my graph goes through the point here at 2, 0, but if it did, what would its slope be? 0, because 0 over a number is 0, right? So these ones are all 0, and the x-axis is all undefined. Okay? The next easiest one, I think, is going to be the diagonals. Because when I have a same number divided by itself, it's going to reduce to 1, right? So if I have 1, 1, it'll be -1 over 1, right? So it'll be -1. So if I have 2, 2, it would be -2 over 2, so it would be -1. And the other diagonal is opposite. I want you to take a couple minutes with your neighbors and finish the other points. So it's 6 in each quadrant. Yeah, I got it in my closet. I don't know where I put it, but it's helpful when I was reducing vector trees today, reducing radicals.
You're welcome, by the way.
Valentina, Fernanda, and I were talking trash today about you. Well, the subject came up of those people that cut weird shapes into the middle of a cake. I know, it seems weird, but it did connect when we were doing volumes. Remember those videos where, like, instead of cutting a cake right, they, like, on purpose do, like, some... And
Like in the
we were
middle?
both like, oh, Valentina would hate that. Oh, yeah.
Cut a cake from the middle. There was one time where I
Like,
ate
if you have
half
a
of
cake
it.
like this, and they cut it like that, just to, like, mess with people who are perfectionists or OCD or something.
Yeah, there was one time we had a pan of brownies, and my brother cut a brownie out of the middle, and I ate half the pan, so then it wasn't out the middle.
Because you had to eat the half of the pan. Okay, who's done? Are you done? At least you look done. No? Okay. Nope. Nope. You're not so sure you're gonna start yet, bro.
-2.
You done? Wow, we'll do that together. You done? You're done. I'm gonna ask you guys what shape you think it's gonna make.
Oh, it's a circle.
Hmm? It's not nice, Chris.
What is it doing?
Equals R squared.
Equals C, which is our R squared. So it is a circle with radius is what's changing. You see? Ah, weird, right? I just need to get the idea.
Okay.
Yeah, just. Okay, so I want you to start taking a look at your shape. What family of function are you starting to visualize here? What family of function do you think this one's going to fit into?
Another conic.
It's a conic. This one's a circle. This one's a whole circle.
It doesn't connect.
Well, but if I had gotten closer to the axes, right, the slopes would have gotten infinitely taller. The circle, remember, at the axis is a vertical line. This one does connect, which is why you have to know a little more information to decide exactly what it is, which is why it's the generals. Does that make sense?
That's the best thing.
No, that's perfect. Okay, so again, notice that I used slopes to make a sketch of my y equation, right? And if I look at it, it's a circle, right? Centered at 0, 0, with the radius changing. Okay, so now let's go through what we did last class and see if we get a circle equation. Okay, so let's start by separating our variables.
You're flicking pieces of plastic.
Now, wait here for me. Okay, wait here for me. Okay. Now, normally, right here, I would have you square root, right?
Are you gonna add x?
Because I want you to visualize the circle. So instead of square rooting, for now, to visualize the circle equation, I'm actually going to have you add the x squared over. Because what I want you to see, pun intended, is the equation of a circle centered at 0, 0, right? Whose radius is what's changing.
That makes so much more sense on the homework when I look on the answer.
Oh, really? Do they
Yeah.
have it written like this? Oh, cool. So they probably want it to look like the equation of the family of function. I bet on the homework they also, I'll show you that one in a second. Let's finish this one out first.
Did they give you like a given point or something?
I didn't assign any that gave you a given point. That's what we're doing next time. So in reality though, if I were solving this on an AP test, because it says y equals, I'd say y equals plus or minus the square root of negative x squared plus c, right? So I just showed you that so that you could visualize the circle there, okay? Do we have any questions so far? I want to say the definition one more time, and I think it might finally make sense to you, okay? A slope field is a graphical representation of all the possible general solution equations
It's like a fuzzy picture.
on a single coordinate axis.
It's like a fuzzy picture of everything.
We should do the Star Wars one now.
Also, fun fact, if you watch episodes 4, 5, and 6 of Star Wars, when they do hyperspeed, this is how they create that effect as well.
Oh.
Mhm.
That's
Imagine when something goes into hyperspeed and the stars and then they go, right? Like that. So slope fields is how they're creating that effect. Anyway, here's what we're gonna do now. I'm gonna give you guys 2 new equations, and I want you, even if you love the algebra, to get the point of this, I want you to do every problem in this order, okay? So for every problem, you're gonna first create a slope field from -3 to 3. Then I want you to guess the function family of y. Then find the general solution y. Everybody know what we're doing? Okay.
Why? What did this thing do to you? I didn't say, when did I say that?
E to the y.
Right first. Did I? It's probably on the recording.
Just estimate, remember E is about 2.719. So E squared a little less than 9, but even if you imagine it as 9, how am I gonna tell?
Which 2.79?
2.719. But like, you don't have to get like a slope of 6, 7, 8, 9, 10 on your slope field. That's all gonna look the same. Just make sure it's like the steepest. You see what I'm saying? Like compare, just have their steepnesses compare the right way.
Honestly, that's what I do. I'm like, when in doubt, I just
E to the
round
Y.
up to 3.
Yeah.
E to the Y.
Y is 3. It's gonna be like,
E to the 0 is 1. So,
yeah, it'll be like 9.
so all of these should have a slope.
It's 2 point, what's the say it's 2? Yes, 3.
You're very good.
Wait, so does the x value not
Wait,
in this one?
2, well, 2.
Yes, and this one the X value does not matter.
Because it's always
good.
Alright.
2 good 8.
And then y is negative 1.
What?
So it's going to be like 1/2.
These are all good.
Are you?
I'm in this.
Alright. Big. I'd rather be
Huh?
tiny.
So it's -1. So y value is -1. So then it'd be another. Because you would be like
Why?
No. Just flat.
Yes, it was.
And then pretty much just flat. Almost flat. Okay, 0 minus
Oh.
0. 1.
What?
I'll try.
What's
The
the
second one is the x-axis.
Oh,
Ew, this one's gonna be nice.
Yep.
I'm only on the positive side.
No.
I don't mind on the second one if you want to use your calculator as a 10 key to help you with the slope field.
Thank you.
Oh, I'm going like.
Oh.
It's gonna go like.
I know, I wanted the practice of the U substitution more than I wanted the no calculator practice.
You substitute. I watched the video again because I just like, and it made more sense the second time.
That's good.
That's normally how it works.
It is. With calculus? Yeah.
I wasn't listening to what
Oh.
they said.
I've been there, sister.
She just likes disagreeing with me to be contrary.
Well, I can't fault her for that.
That's me.
No, no, no.
Please, I am.
I don't know what that's all spelled. I don't know.
Okay.
Miss Summers,
Mhm.
can I run to my last class? I think I left my calculator in there.
Sure.
You know, yeah, it's about 1.5. Yeah.
Pretty sure it's on.
So then it goes like this.
Take me by the tummy. Integrate that one over here. So ln is so value x is equal to x. I'm actually stuck. Oh, we do need a substitution for this. No?
Give her a minute.
This is I don't know the last time you have an absolute value on one side and the other side? How do you make the absolute value on one side?
You have to split it up into its
Piecewise equals piecewise,
The piecewise has 4
And
pieces.
it goes like this.
Goes on both sides.
So the easiest way to do it is to split it over the y
I don't know.
first. So split the y piecewise first. Then split the x piecewise at that point. So in the end, it'll have 4 pieces. Because you have 4 scenarios. If x is positive and y is positive, if x is positive but y is negative, if x is negative but y is positive, if they're both negative, right? There's 4 scenarios.
That sounds fun. I never like piecewise functions.
My name is
I'm thinking, I'm pretty sure it's wrong, but if you have
really doesn't look
You get 0 if you have negative y.
No. What? Now we just have tired. But
So what
I have
is this?
tired.
Don't forget to take your guess of the family of function.
Ding ding. And it goes like this. Dang it, now I have moves like Jagger stuck in my head.
That's
my
what I'm saying.
fault. That is your fault.
I think what you think is in your head is just crazy.
That's probably true. Probably just manifested. I am not on the second one yet because I have a question about integrating on the first one.
Did you do your substitution?
Why would I care?
It's not a 0 error. 0. Y is 0. We have a negative, we have a 0. So those are all.
They're all imaginary.
Those are all aspirations.
What do we do with those? They're all imaginary.
Right?
Oh, that's smart.
Oh my gosh, I'm right. So far, so far.
by 3. Can't say that.
Hey, what function family did you guys guess? Interesting.
Well, isn't it?
You'll see.
Oh, no, no, no. I do not want to
Oh,
know
my cheese.
So help me, if it's logarithmic, I'm not gonna be happy.
Oh, it probably is logarithmic.
I know, that's why I didn't.
It's probably
I know.
Probably
logarithmic.
You're. It was like. So good, right? I'm really good at this.
Spot
I feel
on.
like
Something
messy
like that.
pictures are almost better than like the perfect picture.
That's like almost, yeah.
Yeah.
Yeah, that looks exponential.
Yeah.
The tire's
Yeah.
dead.
Yeah, that looks.
What do I do from here?
I killed the tire.
You have to do something to yell
I have to LN both sides.
What?
Totally looks exponential,
and then take the negative from the wall.
but it's not exponential. It is logarithmic.
No.
But we'll talk about it in a second.
Quizzes.
I just want to make sure. Is there any questions on?
Like, it makes sense why though.
Okay, well, that answers questions. This institution is important.
Totally can see why you guessed exponential because it looks like an exponential, right? But it's actually a logarithmic, and let's talk about why that makes sense. But first, I want to know: is there any questions on the slope field or the algebra of the general solution?
How do you know when to use absolute value?
Good. So you have to think about, well, why is the natural log there? If it's there because I'm just doing like order of operations to cancel something out, it doesn't have an absolute value. If the ln is there because you did a antiderivative rule, right? So like, where does it show up, right? That's when it needs the absolute value.
When it's 1 over like whatever, then you have to have absolute value. Because you can't have the negative, n can be a negative 1.
You got it. Okay? So far okay? Now, a normal, let's see why this makes sense. Why does it look exponential but it's actually logarithmic? Well,
Because it's going this way.
here's why. Normally a log graph looks like that. Is that fair?
But it's
What does the negative out front do for a transformation?
Flip it.
Flips it upside down over the x-axis. What does a negative inside by the x do?
Oh, why?
It mirrors it over
The why?
the y-axis.
So it's like effectively.
Well, hold on. I'm about to
exponential,
make you really angry, probably some of you. Okay? First of all, do you know how sometimes in trig, bear with me, this relates, okay? I can have like a regular sine graph, or I could write like a fancy cosine graph that's been horizontal shifted over,
Yeah.
right? Like sometimes there's easier equations
Yeah.
to write trig stuff. That's like the most often we see that. You guys know what I'm talking about, right?
Yes.
So this actually is an e to the x graph. Here's why. Do you remember how inverse graphs compare to each other? They're a reflection over the line y equals x, which essentially is a reflection over the x-axis and then a reflection over the y-axis. So this essentially is e to the x. It's just a more complicated equation that represents it, that's just a coincidence. It's because the two transformations have the same effect as a mirror over the line y equals x,
The
right?
fact that it's being flipped twice.
Over the x-axis than the y is effectively a transformation. You could have done that in one step by flipping it over the line y equals x. So this just happens to have the same graph as e to the x, but it is a logarithmic equation
The equation is logarithmic, but it's effectively e to the x.
because these two transformations do the same thing as an inverse transformation. Okay? Yeah,
This might be tapping in the next time. But, so when we find C, then we can,
Curtis.
when we find C, then we can know what slope.
When we find C, we can figure out one of the points on the line, and then
which
we
one
can
it
create
is.
the particular solution. That's great. Okay?
Guys, the video, I just wanted to we started doing it.
Yeah, great. Okay, we're gonna move on to this. Have you guys even started this one yet?
Yeah.
No.
Okay, 4 to 5 minutes on this one. We've got plenty of time. There's still 45 minutes left.
45 minutes.
Maybe 40. I don't know. 37 minutes left. We're fine.
Oh, I thought you were saying to do just this problem. I was like, wow.
No, no, no.
Just take a nap.
No, I mean, that is all we have left. We're doing this problem and that's slope fields. I thought I'd do a shorter lesson today so you can have correction time if you want.
What the heck?
Just giving you a little hinty.
Oh.
Little hinty poo.
Hinty poo.
Yeah.
Where are you, Hinty?
Oh, little
Why is
hinty
it
poo.
Yeah.
I think good job.
Why would
Hinty poo. It would.
What was the X value?
Wait, but what? Why can't we negative one? Because you can't take a negative square root. What?
Well, the weird cat is my favorite because it looks like my chihuahua.
You have a chihuahua?
Yeah, it looks
You-
like my little pet boy.
You would have a chihuahua.
I could see
Wait, so you can't take the square root of a negative versus.
Well, but
Ah, I
if you
should-
split it up.
Why are you doing that?
But
Take
with,
negative one square root of
but
one.
with the first version, then the negatives can cancel out, right? Because if you divide negative by negative, then it will be positive.
What are you guys doing?
That's what I was
Well, if you do the.
The,
Like, what are they doing?
no, like the.
I think we're just together.
Oh, you did?
The third quadrant.
What am I
The
doing?
negatives will
Oh, I told you guys you can use your calculator as a 10 key
Yeah.
for this.
Talking about square rooting negatives.
Oh,
Can't do it.
well then they're undefined. So we don't draw a line there like I didn't on the circle example.
No, but then the quadrant 3 is you can graph quadrant 3 because the negatives will cancel each other out.
Oh, obviously.
So that should already kind of give you an idea of what this graph is when I'm done, right? It's a rational function, right?
Yep.
Where it has graphs in opposite quadrants,
Mm-hmm.
right? So that should make it make more sense, not.
So depending on what value you use.
I should probably get up and go.
I understood, so you started spouting this.
Oh, you gotta use the original equation. I'm just showing, yeah, you're right, they won't cancel out technically on the far equation. That was my hint for when you try and get to number 3, the general solution. Yeah, you always use the original. Well, if you would
Well,
ask me
we don't use
that.
it like this kind
I'm pretty sure.
That was what Curtis was
At
talking
least
about.
you do graph
of. Oh, wait, no, it goes
it.
like this. It goes like this.
Okay.
I think it goes like this.
Trying is a keyword here.
Uh-oh.
On the bottom of the dum-dums, I can put it in back. Yeah, and it's pajamas, don't worry about it.
No, I love it. And then you get-
That's matching pants.
Wait, that's
No, those aren't mine. These are for society.
The square root of 1 is 1.
I have a question about the shift, the +1. It's like throwing me off. Do you still represent it in the same point? Or like,
5/3 over square
You're
root.
talking about for the slope field?
yeah.
Yeah. You
Okay.
just plug the two coordinates in
What is
to
this?
X and Y and find that number.
Alright.
Yeah. What?
one quadrant that exists? No, two of the quadrants exist. You want to
Oh,
use
wait, it's a half.
you want to use this one, not this one. This is just the first thing you're going to want to do for step 3. I gave you guys that hint too early. The negatives will cancel and be allowed, so you should be able to plot that in 1 and 3.
You say we're allowed to use it as a 10 key, but can we still root stuff?
Yeah.
Okay.
I don't know.
I think they have square root.
They might. 10 keys actually have about 14 keys. I don't know why they're called 10 keys.
Oh, true.
On a non-calculator, they wouldn't have given you this, so it's fine. I wanted the algebra. I wanted the U substitution
No,
practice.
10 keys don't have a root
No, they
function.
can't cross right.
Oh, let's find out. I have a whole box of them.
Because they have divide, multiply, subtract, add. Then they have
They have
numbers. They do?
Yeah, yeah. I have no idea what the buttons do that have the M's though. I have no idea. I've seen those on a billion calculators. I've never known what they do. Do you guys know what they do? What do the M's do?
Have you tried hitting the M button?
Yeah, and I don't know what it does.
LOL.
Something about saving memory, okay?
Oh, it's a memory?
Something.
Oh, so like memory plus, maybe like it types
I
in
don't know how it
something
works.
like this.
There's no something like
Oh, you're right. It does the last thing I just did again, or reverses it. So every time I press equals, it's just adding 4
Yeah,
over.
it did.
Wow. Yeah, but look, that's handy. Right? I'm just adding 4 over and over. I set it in the memory thing.
This is the
cool?
one
Yes,
right
we
now.
have
It's
a
I did it now.
That's your graph?
that. Did you ever need it?
You do the
Oh,
shape roll
wow.
for the anti, no, wait.
Yeah, these ones, because these are under, right, I just.
Oh, you used to
Ready? Well, frankly, this MRC button is complicated as being
I was thinking of the
simple.
You already moved.
chain rule, which is not a thing.
You guys, you don't overthink too much the slope field. It doesn't have to be perfect. Mostly I wanted the fact that it's only allowed in 2 quadrants to make sense to you why we know the family of function has to be a rational function. You with me? Does that make sense? Okay, cool. So let's go through that. I'm going to go through the algebra now. Okay. Curtis, give me your slope field. I think I saw it when you're done, wasn't it? Yeah. Okay, so Curtis is going to give me a slope field, and then I'm going to start going through the algebra to get the general solution. Okay? Okay, so I'm going to get square root y dy equals square root 2x plus 1 dx. Is that all right? Okay, then I'm going to integrate. U is 2x plus 1, so du is 2 dx, so 1/2 du is dx. So y to the 1/2 dy is 1/2 u to the 1/2 du with the 1/2 in front here. We doing okay? Okay. So then y to the 3/2 over 3/2, 1/2 times u to the 3/2 over 3/2 plus c. So I'm going to keep, change, flip. And plug my u back in. So the 2's cancel here. And I'm going to get rid of the 3's by timesing everything in the problem by 3.
What? Oh, that's. Oh, did I do something wrong then? But if you just move the 3, all you have to divide it, which would be really confused. There's like nobody here today.
I know, it's been like that all my classes.
Oh. Oh.
Curtis has an idea.
An epiphany.
Ew.
Yeah, it's terrible.
This number is
Huh?
Stop.
Stop what?
The equation.
I know.
This is no, wouldn't know.
Yeah. My guess was that it was a rational function too, but it's not. Do you guys see that?
Right, it doesn't.
It's a cube root graph.
Oh.
But can it not go through 0, 0 though?
There might be a hole there.
Yeah.
I don't know how I did.
It's actually probably not a hole. I bet it's a vertical point of inflection
That's what I was
because it's a
thinking.
cube root. Uh-huh.
Well, you plug
It's
0,
a
0.
vertical point of inflection. And the C looks like a vertical shift, but it's not because of the way where it is in.
It's a horizontal shift.
Uh-huh.
He's just so much.
Yeah, it's affecting something.
Yeah.
But there's no possibility of it ever going into the second or fourth quadrant, right? Because there's no plus or minus. It's always a positive 1/2. The plus C is not going to ever flip it upside down, which is why we don't have any pieces in there and there. You guys doing okay?
Oh, because of it. Oh.
No, I have to try.
That's slope fields.
Yay.
You can have the rest of the time to. You can do test corrections. You can.